Okay, in the second half of the class, I'm gonna start talking about some professional terms, or I would say important terms that we use for understanding how to design a battery, or of course, which kind of thing, if it is not about designing a battery, which kind of characteristics we need to consider while we are going to even purchase a battery for different applications. So this is a cool conversation. You guys may also share your experiences if you have any. One of the important terms that you can see here on my screen is cold cranking amperes. In fact, this one is going to look at the range of which kind of range of for temperature we can consider to still have the battery fully functional. What do I mean when I say fully functional? Simply means the battery be able to still start, especially for those who are living in environments, or I would say cities, which is like very cold, including myself. Back then I was living in Quebec. Every day during the winter time, at the end of the day, if you are parking in the parking lot and it's not like covered, we have to connect the car to the outlet. Otherwise, in the morning, we were not able to crank anymore. And somehow we have to just be impacted accordingly. Therefore, cold cranking is something that any automotive industry, I would say battery industry, will include it on the battery. Means they are going to include this information like the temperature, at what temperature rate still your battery is still to go through the normal chemical process or chemical reaction and be able to start the vehicle. That's what we call it cold cranking, or I would say the temperature of the cranking. Therefore, if your battery is maintained even for a short period of time, as I said, even maybe one overnight, in a temperature less than -18, you may lose it in the morning and not to be able to start your vehicle. So for example, in here, most of them, they do have -18 means the cold temperature. In fact, this is again, the cold temperature. Of course, high is also important because remember, if it is really cold, it may stop the chemical reaction, right? It may just bring the material to the frozen point. And then if it is also hot, what would be the impact? I already explained it here and there, but now somebody, if you got the point, what would be the impact of having high temperature? The negative impact. Why we need to make sure that we are maintaining the battery regardless of what kind of the battery is. But in here we are talking about cranking. Cranking is only for automotive. Well, if we are maintaining the battery in high temperature, which is out of the range, simply means we are going to speed up the chemical reaction, right? In here, we may stop it if it is less than -18. In here, if we go above that maximum, which is in this example in here 30, we are gonna speed up. Means we are going to create a dangerous situation that may cause explosion or fire, right? Therefore, it is important to have like the battery, or let's say the vehicle, to be maintained in a normal, based on the standard of that battery, in a situation that still is able to crank, right? So, for example, here you can see most of the manufacturers, they are having some information being displayed or as a label, a stick to the battery. And here it says CA is going to be, for example, this is cranking, right? So this one is going to be cranking ampere, is going to be 1000. CCA is cold cranking ampere, means for the like very cold temperature. And then RC is reserve capacity, is going to be 100. So we have to consider all of those in order to keep the battery fully functional and not to expose it to a situation that we are going to be stuck and not to be able to like run the vehicle. So cranking ampere is number of the ampere, or let's say the amount of the current that the battery, that the battery can provide at zero. How much current the battery can generate or it can provide at zero, right? And then if we say reserve capacity is for something like, for example, at 25, if the battery is giving you 25 ampere, then still we have like a voltage of 1.75 per cell. Why we say per cell? Because we do have numbers of cells. So we have to go through some calculation. So for example, it becomes like 10.5 volts for 12 volt battery. For example, if the maximum of the battery is 12 is the Vmax for the battery. If still we are going to receive 1.75% of it, we are going to have like 10.5 volts out of that 12. So still it is functional. So this one is what we call it reserve capacity, right? Remember, battery has the storage capacity or the storage opportunity. So it can store up to 10.5 volts of that maximum 12 volt. And the other one is the ampere rating. Ampere rating simply is measuring how many amp of the current the battery can produce. Means what's the like the current rate, or we call it current rate or C rate. These are all the same. Current rate, C rate, ampere rating. And this is super important while you are trying to design a fast charging battery. That's why we are, for example, for electric vehicle and hybrid electric vehicle like application, it is super important that the battery has the opportunity or the capacity of handling high C rate. Means, for example, if the maybe capacity of the battery is 10, it can handle, if it is up to 4 times, it can handle 4 times 10 means 40 amp in order to be fast charging, right? That's why it is super important to pick a material that can handle super fast chemical reaction, because when we are going to speed up, or let's say we are going to increase the current, increasing the current means we are going to speed up the chemical reaction inside the battery. But not every battery is able to still stay fully functional and healthy under like high speed or under high current. Why is that? Because it will generate high temperature. And then high temperature, if it is not something that material can handle it, it causes fire, right? Therefore, it is super important to just pick the material which is safe to be charged or discharged with high current in order to design fast charging and like make it like a process which is a speed up for electric vehicle, hybrid electric vehicle application. Another important term, I just said it, C rate. C rate is very common for any battery engineer. And definitely it's going to be a measure of the rate that the battery is discharged. Means, for example, in here, this is a discharge waveform. This is the standard form, not for every single battery with different material is going to be exactly as you can see it in here, but mostly the process is happening with such a curve, a little bit slower or maybe faster based on the C rate. But when we say C rate, means the rate that the battery is going to be discharged. For example, if the battery is 10 amp and we are discharging with 1 C, means we are applying the exact 10 amp. If the battery is 10 amp and we are planning to discharge with 2C, means we are applying 20 amp and so on, right? Therefore, C rate is a discharge rate. And if we go up, for example, in here up to 4C, means 4 amp means fast charging or fast discharging. Now makes sense what is C rate? So it's a factor of the speed or the time. In fact, it is not only the current. Time is super important. For example, for 1 C rate, it takes 1 hour. 1 hour to fully discharge, for example. And then if it takes 1 hour to fully discharge at 10 amp, Definitely at 20 amp, it should be half. 30 minutes. How about 4C? 15 minutes. That's why we call it 15 minutes. That's why we call it fast charge. So try to understand these factors. These are super important. Capacity rate, in fact, again, capacity is the maximum amount of the current that is defined for that certain battery with the manufacturer. You have no option to change the capacity of any batteries. This is done by the manufacturer. But when we say rate capacity effect, means if we are going to multiple times discharge, as I said, the battery health is gonna be impacted. Means the life cycle of the battery is limited. We have limited life cycle. Since we have limited life cycle, that simply means the capacity is gonna be impacted. If at the beginning, this battery is supposed to have like 10 amp, right? And then after some time, and it can hold 10, for example, if we are looking at the capacity, and the C rate is what I said, and it's supposed to maintain 10 amp after some time when it is used, or we call it age. When the battery is aged, it may not be able to maintain the exact maximum amount. That's why we say the capacity effect. Why is that? Because the chemical inside the battery is aged. Therefore, the chemical reaction is not going to happen with the quality that it was happening while the battery was brand new, right? Therefore, we have like capacity effect. And of course, we have internal resistance. Internal resistance means we are going to have like heat generation. And heat generation is another negative impact on the capacity effect. So let's look at this example. Suppose that I'm having a battery with the capacity of 100 amp hour. H in here stands for hour, means per hour it can handle 100 ampere. That's why we always say amp hour. We never say per minute. We say it always per hour. And then now, very similar to what I said at the top, right in here. Now I'm going to say 1C rate is 100 per hour. Now, very similar to that one. If I'm going to speed up, or if I'm going to just go ahead and just maximize it, or fast charge with 5C, means 5 times, right in here, means 5 times 100 ampere. Therefore, I'm going to have 500. If I'm having it 500 amp per hour, also it's not in here, but how long it will take if it is going to be, suppose, for example, discharge at 1C with 100 and take 1 hour. Now I'm applying 5C with equal to 500. How long it will take? Just do the calculation. How do you do it? What's the follow the pattern in here? So if it is like 2, it becomes 30 minutes half. If it is 4, means 60 minutes divided by 4. Now you are gonna have it like 5, means 60 minutes divided by 5. That's the amount of time that it will take for the battery to charge, for example. How much? 12 minutes for the battery to charge it. Now, if you wanted to just scale down, because it's not always a scaling up, fast charging. Sometimes for some different reason, maybe for safety, or maybe for the purpose of measurement and research, or for some different reason, you may want to scale down the charge or discharge. Let's say the charge for now, because we can do both charge or we can do discharge. For example, in that case, if for 1C, it takes, for example, 100 amp at 1 hour, now I'm going to make it half C. Half C, or you can see C over 2. Both of them are the same. Therefore, I have to apply 50 amp. And of course, you have to double your rate, your time rate, means 2 hours. Therefore, if you apply to the battery, which is the maximum current or maximum capacity of the maximum current that can handle, or the maximum capacity at, for example, 1C is 100. Therefore, it takes 2 hours if you apply half of it. Or we have also, so this is C over 2, you can say C over 3, and so on, for the purpose of research, for the purpose of safety, different reason. Make sense? Internal resistance, I just touched the word right in here, but one more time, internal resistance is the resistance which is caused for the flow of electron during the charge and discharge. That's why in here I say flow of charge. So it will cause some negative impact on the capacity because of that heat generation. It causes like the material to be aged, and the material will engage, or it will move the electron from charge to discharge, or the other way around, with less speed. That's why internal resistance. What does it mean when I say slower or less speed? Means, for example, if in the normal situation for a brand new battery with 100 amp per hour capacity, it takes only 1 hour to discharge or charge. Now, if you have internal resistance, it may take maybe 1 hour and 15 minutes or 20 minutes or whatever. And that's a factor of, we call it factor of a state of health, SOH, of the battery. Means the state of health of the battery is impacted. Or in the other words, means the battery is aged. It's not brand new. Therefore, internal resistance is impacting the cell capacity. And SOC in here means a state of charge. If you see it as SOD, which we have it at some point, means a state of discharge. So we have few terms: a state of health, a state of charge, a state of discharge. These are factors which is like really important for designing battery. Another thing is, how do we calculate a state of charge? In fact, a state of charge is the factor which is showing the battery capacity, the current state of the battery capacity. If at full charge, it has to be, let's say, 10 ampere. Right now, at half, what is it? The state of charge, right? Therefore, this is super important. If this is a battery with this state of charge in here in the x-axis, and the cell voltage, this is the voltage, and this is the state of charge is not directly voltage, a state of charge is not directly current, is at the moment how much of the current capacity is able, the maximum current capacity is right in there. What is the maximum capacity, or the percentage of the maximum capacity? I'm gonna write it down. This is a percentage of the, if capacity is C, maximum capacity. Percentage of the maximum capacity is what we call it SOC. Now, for example, this one is the medium current discharge, the state. Suppose if this is like, I don't know, maybe 100, this is 80, right? This is 80, and then if you are coming closer to 0, let's say this is maybe 30% or so on. So this is the high current discharge, SOC. At high current discharge means we are speeding up the process. Therefore, the state of charge is impacted is just 30% or something like that. Cutoff voltage is again another standard defined by the manufacturer. What does it mean? Means for any battery, during the charge and during the discharge, there is a certain rate that the manufacturer understood or examine, test, measurement, all of those stuff in order to maintain the battery in the safe functionality. So they say, for example, maximum voltage and minimum voltage is what we call it cutoff voltage. Maximum for charge and minimum for discharge. That's what we call it cutoff voltage. Means when you are connecting your cell phone to the wall, if the maximum voltage for that certain battery has been defined to be, for example, 4.5 volt, never go above this. Do not increase it to 5 volts. That's gonna damage the battery. Also, for your cell phone, you do have built-in BMS system, so you won't be able to really do it. But still, if the battery is out and it's not connected to a battery management system to cut the flow of power to it, maximum is 4.5, means this is the cutoff voltage. Never go above this. And then, for example, for minimum, usually is either 2.5, 2.3, or 2.4 based on the manufacturer. Means while you are discharging the battery, never fully discharge the battery to 0 if you do not have, again, BMS. Stop right at this range, which is like defined by the manufacturer, to avoid damaging the battery chemical. That's what you have to consider. Cycle life, we already discussed it one more time. A full cycle, you have to first understand what is a full cycle. For example, this is a charge, right? This is a discharge. And then in the previous slide, also you had a discharge. A full battery cycle is a combination, I'm going to draw it right in here, a combination of a discharge and a charge. That's what we call it, a full cycle. Means, for example, the battery starts discharging up to this point, and then the profile of charge is exactly reverse. It's like this, right? Therefore, if this is the discharge plus charge is going to give you a cycle, a full cycle. Therefore, when we say cycle life, means number of discharge and discharge is being defined by the manufacturer. And that's what it can define the life cycle of that battery. For example, they go ahead and say this battery is fully functional and it's supposed to stay fully functional for 3,000 cycle, or maybe 5,000, or whatever, based on that certain battery. That's what we call it, cycle life. If you maintain the battery in a proper situation in terms of charging and discharging, maximum and minimum voltage, in terms of temperature, and all of those stuff, and everything is just properly done about the battery, then it's supposed to give you 3,000 cycles. But if you do not treat the battery in a proper way, definitely, if it's supposed to give you 3,000, it may be impacted, and after maybe 2,000 cycles, the battery is damaged and you have to replace it. That's super important. And most of the time, fast charging, discharging could be something that you can consider in order to avoid damaging the battery, especially because it will cause heat, and heat is the enemy of the battery, right? Any questions so far? So far, we were talking about SOC, SOD, SOH, and I'm expecting everybody have a good understanding of these terms. Another remaining terms which I'm going to bring it to your attention is DOD. DOD is very similar to VMIN, means discharge, right? Means depths of discharge. So how discharge is, how much charge is released from the battery. That's what we call it, like depths of discharge, right in here. And you can see higher depths of discharge, lower cycle life. What does that mean? Means if you are going to discharge the battery with like high C rate too many times, you are gonna impact the cycle life and you are gonna reduce the standard cycle life for that certain battery. Make sense, kids? Next is a good part. In this part, we are gonna start gradually learning some calculation. Maybe not in this exact slide, but it's super important to learn these terms, and then we are gonna put some equation behind them, and after that, gradually learn how to do this one. So let's start with a specific energy of the battery. A specific energy, as you can see just right in here, is a factor of weight. Means simply like how much, like the measure of how much energy a battery can handle based on the weight. So it is super important to know the weight, and the unit is kg. Of course, if it is a different unit, you can convert it. Therefore, it's a factor of the mass. In here, mass of the battery is important, or the weight of the battery is important. So it's watt hour per kilogram. If it is anything else, you can convert it. So it's the energy per unit mass, watt hour per kilogram. But how about energy density? Any idea? Energy density is watt hour per, what is this one? Per liter. Actually, per volume, we could say. Here it is per mass, here is volume, which is liter, right? Therefore, do not confuse these two. This is how much energy per mass. This is how much energy per volume. That's the difference between these two. Means energy density defines the battery capacity like in liter, right? In volumetric energy density. Volumetric energy density. That's how this one can be defined. Now, if the formula of the power, we know it, we practice it one more time, P, and the unit is watt, is going to be what? IV. Then a specific energy is what? A specific energy is like the nominal battery voltage. A specific energy is the battery voltage, nominal battery voltage for what? Times the current. What else? Divided by weight. Divided by weight, which is, what is the unit for the weight? Kilogram. And this is weight. That's how we can calculate it. You can simply come up with the equation if you have a good understanding, or you can remember it. Now you have that one. So a specific energy is battery nominal voltage times the rated battery capacity. I'm going to say it like this. This is battery capacity is talking about the current, but I'm going to use the capacity. So it's going to be voltage times capacity called specific energy. Makes sense now? That's the specific energy. I'm gonna just use the water in bottle. So suppose that water inside the bottle, in order to understand this one. If this is a bottle, maybe, and you have some water inside this one. Water inside this one is going to be your specific energy or energy density, either of them. Energy density, which is volumetric, or a specific energy, which is mass, either of them. We can call it a specific energy or energy density, either of them. But if you are gonna just maybe release the water, if you are gonna hold it like this, and release a little bit of this water right in here to come out of it. Also, that one was SE, it depends which one you want, or ED. Then whatever in here, the water which is coming to another, maybe this one is gonna be the power, the specific, because I'm gonna explain this one. A specific power. What is the unit for this one? Watt. Why do I use this example? Because a specific energy has a source, and it's a factor of how much water I have in here, or what's the volume of the water, either volumetric or mass. What's the mass of the water? What's the volume of the water, either. But when I say what's a specific power, means the maximum power per unit mass. Means when this water is just releasing from the bottle, what's the power of it? That's what we call it a specific power. Make sense? Makes it easier for you to understand? So water in the bottle represents the capacity. I'm going to say capacity. And then you can use either of the term volumetric, or you can use, like, for example, if it is mass. And then the pouring the water is the loading, or the pouring the water into another maybe dish or whatever is the power. Make sense so far? So now let's look at this graph. Now you have that understanding of different terms. This graph is showing the specific energy. This is the energy density. And this is the energy density for different type of the battery. So it's a specific energy for different material or different battery type. Like, for example, lead acid, nickel, or nickel, manganese, lithium ion, or whatever, different type of the battery. So the change is respected to energy density, and moving from lead acid to lithium metal. First thing first, this guy is not really safe to use, but this one is really safe to use. We already discussed it. Why is that? Moving from to here, look at how the energy density is changing. Lead acid has less energy density, maybe, for example, right in here at around 40 or so, right? And then in here, metal, lead metal is going to have like something maybe 210 or so on, right around here. So then, of course, I would say lithium ion is in a very good like standing point. That's why it is more common for application, for like such as highest speed applications, such as electric vehicle and hybrid electric vehicle. But how about the rest? No, this one is not safe, because it will cause a lot of heat and it will become unsafe in order to use it. So let me just finish this one. And then hopefully next session, I'm going to start with lithium ion and a little bit more about lithium ion by itself. It has like a lot of discussion to go through it. So if you have any question, feel free to ask. Any questions so far? The last one, which I'm going to bring it to your attention, is about, since so far we have more discussion about lead acid batteries, which is very common for combustion engine. And now on, we are going to change our focus for non-combustion engine, means electric vehicle, hybrid electric vehicle. Now we are going to look at nickel metal hybrid, and of course, it's a type of, again, secondary batteries or rechargeable batteries, right? So what's the benefit in here? In here, negative electrode is nickel metal hybrid. When we talk about this one is the negative electrode, means write this one. If this is the negative, this is nickel metal hybrid. So when we have the cell to be charged, if this is during the charge, positive electrode release hydrogen. This is hydrogen. During the charge, if this is negative and this is positive, the process is happening this way. Therefore, it's going to release hydrogen. And during the discharge, it's going to be otherwise. And the hydrogen is supposed to come to separator or the solution. And from here, look at here, the entire plates are just covered with this solution or electrolyte. Therefore, this electrolyte is supposed to make it easier for the hydrogen to be moved, right? So hydrogen is going to absorb and store some hydrogen, will store some negative electrode. And then we'll pass it to right in here. Look at here, I'm having negative electrode in here. And that's what during the discharge is happening. So then it will generate something. If I'm going to just come up with the chemical, it will generate nickel oxide like 2, which is nickel hydroxide, which is going to be after the positive and negative charge. You do not need to just really go through all of the chemical reaction, but understanding them is really good. So then that one will be, this nickel hydroxide will be moved to next plate, right? And in here I'm having water. This one is water, in order to use as an electrolyte. And definitely one free electron is going to be mixed with it, and then I'm gonna have a process. Let me just write down the full process during the positive. During the positive, I have Ni, if you want to take a note, this is a good one to learn, plus this one, OH. During the charge, this is gonna give me, because this is a reverse, has a reverse process. During the charge, this is gonna give me NiOOH plus water plus that negative electron I just said, E minus. And then you can reverse it during discharge. During discharge, everything could be reversed. This is what it is happening in positive electrode. In negative electrode, you have M plus water plus that negative electron. Again, it could be both way, and this is gonna give you MH plus OH. And then if you want the overall reaction, I'm gonna write down the overall reaction for you. NiOH, if I recall it properly, it was M. Again, this is both direction. And then you get this one, NiOOH plus this one, MH. This is the complete process during charge and discharge. So if you have any question, feel free to ask. But generally, each cell make almost, in this one, each cell, it makes almost 1.2 volts. And this type of battery, they do have the option in order to be charged and discharged in high C rate. That's why I say they have higher specific energy. And then they can be generated in larger sizes. They do not have limitation about how big the cell could be. And of course, in here, electrolyte, which is this part, this is the electrolyte, it doesn't react with a steel. A steel is the housing or the casing. So electrolyte also, it is inside here. You can see it, it won't react with the housing or with the case. This is super important. And then these are environmentally friendly. They are not gonna like generate any harm for the nature, for the human. And definitely they can maintain their life cycle for a long period of time. Then they are a good option also for like durability. They are really durable, but still they do have, like, for example, a high rate of self-discharge. What does that mean? It means even if you are not using them, you are leaving them to sit right in there, like in the corner. You have nothing to do with them. Still, the chemical reaction is active inside them, causing self-discharge. So that's the maybe only disadvantage of nickel metal hybrid. So I'm going to stop it right in here. Feel free to bring any of your questions to my attention. So any question?